This is the May 2011 Paper 2 Problem 3. In this problem, we have a function given, x cubed plus 48 over x, and we're given a domain restriction that x cannot be equal to 0, which makes sense to us. We recognize this function as a rational function, and we know that we can't divide by 0, and it makes sense that x is not allowed to be equal to 0. The first part of the question, part A, is very straightforward. We're calculating the function at a value of 2, an x value of 2. So we're going to write an equation. The function evaluated at 2 is equal to 2 cubed plus 48 over 2, and we calculate that that is equal to 32. Secondly, we're asked to sketch the graph of the function, and they give us a window range, basically. They say we're going to look at x values between -5 and 5, and at y values between -200 and +200. I've cut and pasted the answer key, and I want to talk through some points on the key and things that you need to be looking for. So first of all, you'll be getting an accuracy point for labels and an indication of scale. So now, again, even if you're just sketching on IB graph paper, use the entire sheet of paper for your graph. Don't make your IB grader look for some little graph that you've got snuggled up in the corner of a whole sheet of graph paper. Use the entire piece of graph paper. So here are x values were given to us between -5 and +5. I'm going to go ahead and fill the rest of these in so you can see. There's my scale. I've labeled the x-axis x. I've labeled the y-axis y. And I've got the blocks on this scale going between in units of 50. So we've got -50, -100, -150, and -200. So you want to make sure that the scale is clearly indicated on your graph. Now, they're also giving you a point for the correct shape of the two unconnected smooth branches. The reason that they're kind of emphasizing that unconnected is that we've got a vertical asymptote. We know that x can't be 0. We're not allowed to divide by 0. We've got a vertical asymptote at x equals 0, and I'd go ahead and mark that asymptote right there on the graph. And you want to show that your graph approaches but doesn't touch or cross over the vertical asymptote. Now you're also going to be given, we talked about asymptotic behavior, you're also going to be given a fourth point for having the max and min in approximately the correct position. So even though it says sketch, we're looking for an accurate representation of the function. And the maximum value right here and the minimum value need to be located appropriately on the graph. Part C asks for the first derivative. So we're calculating the first derivative. And to do that, I would first rewrite the function x cubed plus 48x to the -1. I'd like to rewrite that with a negative exponent because now we're going to use the power rule. And we know that the first derivative is 3x squared minus, we're going to bring the -1 and multiply it to 48, -48x, and -1 reduced by 1 power is x to the -2. So we could also write that as the f prime of x is equal to 3x squared minus 48 over x squared. Either of those would be acceptable answers. And in part D, we are asked to evaluate the first derivative. So we're going to find what f prime of 2 is. So we've got 3, and you remember, this is a paper 2 question. I know I keep repeating this, but you've got to show your work. So if you're substituting a value into an equation, show the substitution. So 3 times 2 squared minus 48 divided by 2 squared is equal to 0. Show that calculation, and right now bells and whistles should be going off, because what does it mean when the first derivative is equal to 0? I'm going to go back over to my graph. That makes sense because I evaluated this function at 2, and right here at 2 I've got a slope of 0, and that means I've got a minimum value on my graph. The tangent line has a slope of 0. because this graph is symmetrical, I can kind of see over here that at -2, I'm also going to have a slope of 0. And it says to write down the coordinates of the local maximum point. And so I know that my maximum point is at -2. And I need to find the y value. Well, the y value at +2 was 32. The y value at -2 is -32. But you can go ahead and use the trace feature on your calculator to confirm that. Find the range of the function. Let's look back at the graph and talk about the range. The range goes from -infinity, so I'm going from -infinity up to this maximum value. And then I stop. And I don't have any values of y or any values of the function in between this -32 value and the +32 value. And then my range continues towards +infinity. So I want to write that using interval notation. So my range goes from -infinity to -32 union +32 to +infinity. Next, I'm asked to find the slope of the tangent to the graph at x equals 1. At x equals 1, so right here, I'm going to be finding the slope of this line. Here I'm tangent to the graph at 1, and I want to find the slope of that line. So I know that the first derivative is the slope function, and I'm going to be evaluating this first derivative at 1. So I've got 3 times 1 squared minus 48 over 1, and my first derivative is equal to -45. That means the slope of that tangent line is equal to -45. And now I'm asked to find a second point on the graph at which the tangent is parallel to that. It's also equal to -45. So I can do a couple things. I could say, well, the first derivative has to be equal to 45, and I can solve for x. So I'm going to say, where is that first derivative? 3x squared minus 48 over x squared equal to -45. And I could go to y equals, and I could put -45 into y1, and I could put 3x squared minus 48 divided by x squared. Remember, when you divide, put that into parentheses, into y2, and solve for where they intersect. Or I could look on my graph and say, well, I'd like to find a place where I've got a line parallel, because I know they have to have the same, okay, that doesn't look good. I know they have to have the same slope. So since this graph is symmetrical, I can see that those two parallel lines, that's going to happen right here at -1, at the x value of -1. And if you're going to solve a problem using that method, to get the method point, you're going to have to show on the graph those parallel lines and show the tangent line. And so I can see that at x equal -1 is where I also have a slope of -45.